Welcome friends, welcome to our YouTube channel Crystal Learning. Here we will learning some concepts through numerical problems which will help you to understand the subject in a better way. So this question is of hydraulic machine subject, and we will see that this question came in SSC-JE to 2017 evening batch. Okay, so let's see the question. When a piping system is made primarily of vertical lift and very little pipe friction, the pump characteristics should be horizontal, steep, nearly horizontal, first rise and then fall. So before attempting this question, let's understand the concept behind solving this question, because if you are just blatantly memorizing the options, then there will be a lot of question and the brain capacity will be used in just rote learning. But if you understand the question, definitely you can save that space in your brain to learn some other concepts. So it is always advisable to understand the question rather than just blatantly rote learning or memorizing the options. Because if there is sudden twist in that question and the topic is same, then you won't be able to do that question. So now let's see some theory related to this question. So when we will study the pump performance in hydraulic machine, a point will come that is known as operating point. So we know when pump is operating, there are in between supply tank and discharge tank, there is piping system in between. So piping system has its own system curve, some definitions, or I would say some terms which you must keep in mind before attempting this question. First is system curve. So system curve is related to piping system, and pump is related to own performance curve. Means pump, when you buy from a manufacturer, so its performance curve is fixed depending upon the geometry and the instrument used in that. So the intersection of these two curves is known as operating point, and we know that system operates only on its system curve and pump will operate on its performance curve. Just wait for a few seconds. When we will see the diagram about this system curve and performance curve, we will get much more understanding. So now coming back to again new term, that is static head. What is static head? Static head is defined as the vertical lift of the fluid that pump has to operate. Okay, pump has to operate. So vertical lift, in the question it is asked vertical lift. Vertical lift is also known as static head. Okay, so static head is the height of the water has to travel. It moves through your discharge pipe. Or static head is the vertical distance the liquid travels from supply tank to discharge point. So here we define it from this level to this level. The vertical distance is known as static head. Another very important point we have to know here is static head is constant at all times, assuming a constant source level. It is known that actually you are taking out water, so level will decrease, but we assume that level is constant, level is not changing, and this is the discharge point. Up to this level it has to be filled. So static head will remain constant throughout the operation. Okay, it is our assumption. So now if we talk about total head, so total head will be sum of static head, okay, plus all the losses of friction head, because in between there will be piping system and piping losses will be there. So you have to give more power to the pump in form of head. That will be considered of static head known as vertical lift, and sum of all losses known as friction head. So these are all about vertical lift and friction head. So that terminology is clear now. Now let's see the various pump curve shapes which you find in centrifugal pump. So this is gradually rising, then steep, then flat, then drooping. Let's see the shape of this curve. Okay. So here it will be discharge, and here it will be head. So these things will be studied in detail when we go through the theoretical lectures. Okay. So first drooping curve is head will increase and then decrease. Flat curve will be a flat characteristic of the pump curve. Steep will be sudden drop. Okay. And this gradually rising will be like this. Okay. So now we have to build this curve depending upon the data given in the question. So if we talk about the pump characteristic curve, this dashed line, this red line is the pump characteristic curve, and system curve is this black one, okay, and it consists of total head and friction. So where they will intersect, that is known as operating point, okay. So total head will remain constant throughout the operation. This friction head will vary upon depending upon the system curve. So if the question is saying, if we see that system curve OB, this one, OB, this is the system curve OB, a pump characteristic curve AB is looking flat. But for what condition? When this friction head is more in comparison to friction head. Friction head is greater than this static head or vertical lift. So we will get a flat type of pump characteristic. Okay. So this will shift in this direction. But in the question it is saying that primarily vertical lift, means here the condition is friction or vertical lift is greater than friction head. So this point will shift in this direction here. So here we see that friction head is decreasing. Okay. So mainly it is total static head or vertical lift. So we will get a pump characteristic like steep. Okay. But suppose that it is somewhat here, then that is known as nearly horizontal or gradually increasing, and this is flat. So now, so what will be the answer? So we know this is a primarily vertical lift curve AC. We will get curve AC, and that is known as steep curve. Okay, steep characteristic. So coming back to the options, let's see. So when piping system is made of primarily vertical lift and very little, the pump characteristic would be option C, steep. I hope you understood the question, and there will be no need to just mug up the answer. Okay. Meet you next time. Till then, enjoy the day.